Here's 2019 question 3. As of this point, there's no more calculator allowed, but doesn't mean that it's difficult. In most cases, actually, it makes it a little bit easier to solve. Okay. Here we go. So looking at this, it looks like a graph analysis problem. Right away, I'm going to identify what the graph represents. It's the graph of f. I'll read this through. Okay, so they give us this random fact here. It might seem meaningless now, but I'm sure we're going to have to use it later. At 3, the y value is 3 minus rad 5. So right about here is what they're referring to. But let's see how that comes into play, okay? All right, part A. If the integral of f from negative 6 to 5 is 7, find the value from negative 6 to negative 2. Okay, so you see these type of problems on your multiple choice. You might not have remembered it because it's been so long, but imagine this, okay? Going from negative 6 to 5 is the same thing as going from negative 6 to negative 2. And then going from negative 2 to 5. Okay? I already know that I want to look for the integral from negative 6 to negative 2, which is this one right here. So if I isolate that, I'm going to move this guy over here by subtracting. So negative 6 to negative 2 of f of x dx. If I integrate that, that's going to be the same thing as integrating from negative 6 to 5, but then subtracting negative 2 to 5. Wait, did I do this right? Yeah, it looks good. Okay. So what do I know? I know that the integral from negative 5 to 6, negative 6 to 5 is given right here as 7. So this is just 7 minus whatever that is. So the integral of f from negative 2 to 5 is basically this. I'm going to color it in. Okay, there's a lot going on, and you can actually make this a little bit easier. So I want you guys to take a look. I shaded pretty much everything in between the curve and the x-axis from negative 2 to 5. If you notice, from negative 2 to negative 1, and from negative 1 to 0, they actually have exactly the same area, but opposites. So there's no need to calculate that because you know it's going to add up to 0. Same idea here. This red area here and this green area right here will cancel out as well. They have the same amount of area. So we could actually ignore that and just look at from 1 to 5 to kind of speed up the process here, okay? So let me start at 1. I noticed that at 1 all the way to 2, that's a shape of a trapezoid. So that's just 1/2 times the height, which is the horizontal distance, and the length of the two bases. So if you tilt your head sideways, the length of the two bases are 1 and 3. Okay? So that's equals equal. I'm just going to leave that there. That's the area. I know it's going to be positive. But what's left is, let me choose a different color. This area right here. Now, normally we can't find areas under curves without knowing the actual function. But in this case, that curve happens to be a quarter circle. Okay, so how do I find this purple part, right? So what you guys do is, what I could do is I could find the area of that giant square, which is a 3 by 3, okay? So that area there is 9, okay? And if I subtract out that quarter circle, I can get what I want, that purple area. Okay? So that purple area is really just the square minus that quarter circle. So that quarter circle is going to be 1/4 for a quarter, and pi r squared for the area of a circle. Now the radius of that is going to be 3. Okay? So we're just going to smush everything all together. It's going to be the area of a trapezoid, so 1/2 times 1 times 1 plus 3, plus the area of that square, which is 9, minus the area of that quarter circle. There's no need to simplify, but that's basically what you have to do there. The first obstacle is knowing how this can be manipulated. The second part is just finding the areas, okay? So there was a lot of pieces to this puzzle here. Okay, here we go. Part B. They want us to evaluate 2f prime of x plus 4 from 3 to 5. Okay, so here we go. Right away, I'm going to rewrite it as 2 integral of f prime of x dx from 3 to 5 plus the integral from 3 to 5 of 4 dx. Okay, constants and coefficients can be separated from the integral. So right away I notice that if I integrate a derivative, I should just get the function. So this is really just 2 f of x. Okay, and the integral of 4 is really just 4x. Okay, I won't do the rest, but the last part is you putting in your upper. Actually, I need to go further. Okay, so this is going to be 2 times f of 5 minus f of 3 plus 4 times 5 minus 3. Okay? This last part here, I'm going to leave it because equals equal. The only thing that's left uncertain is what these values are right here in the quantity. F of 5, if you look at the picture, f of 5 is 0. Well, what's f of 3? F of 3 is actually given right here. They told us at the very beginning that at 3, the value is at 3 minus rad 5. 3 minus rad 5. Okay? So if you decide to continue, beware, be very cautious. But why would you? Right? Equals equal. You don't want to lose out on simple points there, okay? That's it for part B. Okay, I'm going to make some space here. So in part C, they're asking us, okay, so they're introducing a new function g, okay, which is the integral of f, but from -2 all the way to some number x. Okay, so we know that g is this. And we want to find the absolute maximum value. Okay, here we go. Absolute maximums can occur at the endpoints, -2, 5, and at a critical number. So pretty much where the derivative, g prime would just be the derivative of the integral of f, which is just f. Okay, we set that equal to 0. So since we have the graph of f, where's the graph of f? 0. Okay, the graph of f is 0 at 3 different locations, -1, a half, and at 5. -1, a half, and at 5. So you could rule out a few, okay? Actually, just one here. Since f goes from positive to negative here, we know that's a local minimum, okay? Sorry, a local maximum. So a local maximum could be an absolute maximum. So we'll leave that there. But at 0.5 here, notice how f goes from negative values to positive values, implying that that's a local minimum. So we could actually rule out one half so that we do less work there. Okay? So here we go. It's just a lot of plug and chug. but this is the integral from -2 to -2. This is going to be the integral from -2 to -1. And this is going to be an integral from -2 to 5. Okay? The integral from -2 to 2, I know I didn't write it properly, but if you're not moving anywhere, you're not accumulating anything. Okay? Make sure that that makes sense to you before you move on. Okay? The integral from -2 to -1. So from -2 to -1, that is just the triangle there. 1/2 base times height should just be 1/2. Okay, and from -2 to 5, well, we did that in part. Hold on. We did it somewhere. -6 to -2, -2. Hold on one second. Brain fart. Okay, so the answer from -6 to -2. So what do we want? What am I missing? -2 to -5. Sorry, -2 to 5. Yes, was from part A. -2 to 5 was pretty much the area from -2 to 5. I think we found out that it was everything in black right here. Okay? Which comes out to, I'm going to cheat a little bit. That's going to be 11 minus 9 pi over 4. I think I'm getting this right. Because it was the initial value 7 minus. So this is just the black stuff. Okay. 9 pi over 4. Remember, pi is about 3. So 3 times 9 is 27. If you divide that by 4, you're getting what? 7-ish. Okay, so 11 minus 7 is about 4. Okay, this is roughly 4. Just to eyeball it. I wouldn't write that down, but we're looking for the absolute max, so you would just say that it's going to be 11 minus 9 pi over 4. Since it is the largest value, it can't be 0 or 1/2 here, okay? That was gross. Okay, last one, part D. So that's the downside to erasing stuff. You actually might need it for later. Okay, part D. They asked us to find the limit. Okay, so right away, even though limit problems don't pop up often, they can for this year. First thing you want to do is you want to try to plug it in. Let's see what happens, and oftentimes something probably won't work, okay? Okay, so I know that 10 to the first is just 10 minus 3 times, well, what's f prime of 1? F prime just means the slope here at 1. So the slope, it's looking like it's rising 2, running 1 on that line. So a positive 2. All over f of 1. F of 1 looks like it's at 1 in the picture. Arctan of 1, okay? What's arctan of 1? Okay, so if you guys remember back in trig, tangent is pretty much sine over cosine. Okay? We want tangent to come out to 1, which implies that sine and cosine have to be the same, right? At what angle will sine and cosine have the same value? Right? So that's at pi over 4. Okay? At pi over 4, sine is rad 2 over 2. At cosine of pi over 4, it's rad 2 over 2. So it makes sense, okay? Oh, and that's it. We actually got a value. There's no need to use the Hopital's rule. Actually, do you even need to compute arctan? Right? You know what? I'm going to go back. Screw that. Let's just leave it as arctan of 1 equal is equal. You're all done there. Okay?